Good morning everyone, this is Alex Tesh from HPE and today we are going to showcase a Mapr installer that we have developed for DCOS. What we can see from here is my Git repo and from here we can actually clone or pull this particular application that is going to deploy Mapr on DCOS. And if we follow the readme.md file, we can see that the installation is quite simple. So basically we just need to create a definition of our DCOS agents in the host file and then mention there how many containers we want to run for our Mapr cluster. Once we have these definitions in place, then we just need to run this particular playbook called config processor, and this playbook is actually going to generate the main.yaml playbook, which is going to do the installation. It's also going to create the JSON files with all the definitions for the Mapr containers, and it's going to add additional playbooks for the data nodes. Since we can have as many data nodes as we want, then basically we just need to add the name of these data nodes inside the host file, and all the playbooks for those data nodes for the deployment will be created by this config processor playbook. Okay, lastly, we will run the main.yaml playbook that was created by config processor, and this is the one that is going to deploy the infrastructure. Let's quickly just take a look at this particular server, which I used to clone my Git repo. And if we take a look at the host file, from here we can actually see that we have the definitions for our Mesos agents. So I have one public agent, like we can see from here, and this agent is the one that will be hosting Marathon LB, presenting all the ports that we will need to use for Mapr. We will have a few private agents. In this case, I have created a definition for 5 agents. The very first one, by default, is the one that we use for the Mapr controller, and the subsequent ones, we use them for the data nodes. So in this case, I will have 1 controller and 4 data nodes, since I have 5 Mesos agents for private. Okay, we have to create also definitions for some variables. In Mapr, we're going to need a dedicated LAN, and we need to create this storage variable definition, which is going to be pointing to that LAN. We have to keep in mind that all the data residing on that LAN will be destroyed. It will be grabbed by Mapr, and it will be used by HDFS. From here, we can also define the container name that we want to give to our Mapr host. So in this particular case, I am calling the controller comc1, and then for the data nodes, I am just calling them data1, data2, data3, and so on. We have to define as well the IP for the container. We are using IP per container for the Mapr deployment, so it's very easy to guess the IP that the container is going to grab. We just need to take a look at the Mesos agent and see in which particular segment they are sitting for the network overlay, and then basically just grab the next IP index segment, in this case 130. And finally, we can define the name of the cluster, what we want the cluster to be named. Okay, so after we have all the definitions in our host file, what I will do is just proceed to run the config processor playbook, pointing to my host file. And this playbook is going to generate our main.yaml file, is going to create also the JSON files for Marathon to create the Mapr containers, and also is going to create the additional playbooks for the data nodes, like we can see from here. So if we take a look at the directory, the main.yaml file should be there already. Before I run it, let me just quickly take a look at my DCOS environment. So from here we can see that only Marathon LB is running in the public agent. There are no other services at the moment. Okay, so let's just quickly go ahead and run our playbook main.yaml pointing to our host file. Okay, we should be able to see that the controller is going to start to come up. Okay, this process takes roughly about 2 minutes. Actually, it's less than 2 minutes, but I am creating a pause for 120 seconds just to give some chance to the container to fully deploy the Mapr binaries and get the CLDB going. And once this portion finish, we will see that the comc is going to be in green status. We have a monitoring agent also in place, so we are checking the health status of this container, which is based in this case on probing the port 10,001, which is the one running the Mapr system console. Okay, I will leave you for a few seconds whilst this one finish running, and I will be back once the playbook is continuing after this particular task. Alright, we're back. The playbook continued to run. So what we can see from here is that we are creating a directory under Mapr.fs, which is HDFS, and this directory is going to be used for the Spark log files. So by default, Spark History server is going to fail during the deployment because it doesn't have any directory to host the files. So we are just making sure that the playbook creates this directory. We can see right now that we are spawning the remaining containers, which are basically the data nodes, and we can also see that our controller status is currently green. So we are already monitoring this. So the next portion in the playbooks is going to install the packages that we're going to be using in the Mapr cluster. So I am installing Job Tracker and also Spark. Okay. And after we install these additional packages, obviously we need to reconfigure the services. So all of this is done as well as part of the playbooks. I am pausing for 30 more seconds to let the data nodes finish the configuration, and after this what the playbook will do is going to copy the host file to all the containers so that the controller knows how to reach all the remaining data nodes. And we need this when we want to submit jobs so that the controller know how to reach them. For example, if we want to run a TerraGen or a TerraSort, the controller needs to know how to reach the data nodes and assign jobs to them. Okay. Finally, we're going to install RPC bind, and we are going to need RPC bind basically to run Mapr NFS, which requires an enterprise license. Okay. As part of these playbooks, we are also creating some tenants and some users. We want to showcase the multi-tenant capabilities that we have in Mapr. So what I am doing is basically creating a few volumes that are going to belong to two different tenants. We're going to have a marketing tenant and a development tenant, and we're going to have two users, one for each tenant. We're going to have Sharon sitting on the marketing department, and we're going to have Mark sitting on the development department. These users are going to have two volumes each, and these volumes are going to form part of the topology that we will see later in the Mapr console, so that every time that they submit a job and store some data in HDFS, the other departments are not able to access their data. Okay, so that's how we achieve multi-tenancy. So from here we can see that we are creating the volumes already, and the playbook is almost done. So what I will do in the meantime is probably let me try to start accessing this controller. We can see that everything finished successfully. So the controller is actually sitting in my public agent, okay, in this particular port 10,001. So if we point to that port, we should be able to reach the Mapr system console. Let's accept the license agreement that we have, and from here we can see the topology. We can see that we have two nodes that were assigned to the development tenant, okay, and they are sitting on separate racks. So one of them is in rack 1, the other one in rack 2, and we have three additional nodes for the marketing tenant and again they are sitting on different racks for redundancy. We can see an amber light here, and the reason why we see this light, like I mentioned before, is because of Spark History Server. By default it fails during the deployment because we don't have a directory under HDFS to store the logs. So what I will do is let me just restart the service, and this one should be able to come up smoothly. Okay, so we have a few volumes here, obviously, that we create by the Ansible playbooks. Like I mentioned before, I created some volumes for the marketing tenant, and I created some other volumes for the development tenant. If we take a look at them, the topology is all pointing to /data, so we still haven't applied a multi-tenancy. In order to change the topology, we don't have the option here. I will need to apply an enterprise license. So not to worry, I will apply for a 30 days license. We just need to go to manage license, take note of the cluster ID that we have, and then by going to my mapr.com/user, we should be able to add a new cluster. So what I will do is quickly, let me just write the ID of my cluster. I will need the name as well, which is actually here, the one that we define in our playbook variables. We just write down the name here, and I will need an enterprise license for this particular cluster so that we can actually have NFS and we can actually configure multi-tenancy for the volumes. So obviously I have quite a number of clusters here. Let me just double check which one is the one that I am supposed to use. It ends with 132, so let me check which one is 132. 132, this is the one. Okay, and the easier way to add the key is just to copy and paste from the browser. So let me just quickly try to select everything from here, and let's go back to our Mapr console and add the license via copy and paste. Okay, license add, apply licenses, and there you go. Now we have an enterprise Mapr cluster up and running. So if we check the Cobra Dev and Cobra Prod, all the volumes, we should have the option to actually move them. I am not going to manually move them. As part of the deployment, what I have done is I have created a script and I put it inside the Mapr controller, and that script is going to configure the volumes inside the respective tenants. So let's just quickly SSH as user Mapr to our controller node, which is sitting in 2130 like we saw in the host file. The default password is Mapr, and then from here we should be able to see the script for volume topology. Okay, so let me just quickly run it. This functionality requires enterprise license, which we already key in for 30 days, and it runs pretty quickly. If I close this portion and I open my volume again, we should be able that it's actually sitting on a different topology. This is the development topology. So my user sitting on marketing shouldn't be able to see these two volumes that are sitting on the development tenant. And obviously my marketing users, they have their own volumes, which are sitting on /mkt. Okay, so this one is just to showcase the multi-tenancy capabilities. Obviously their users in the respective tenants will have read and write access to their own volumes. And what I will do now is just quickly, let's run a TeraGen test just to make sure that everything is kind of working fine in our cluster. Okay, so like I mentioned before, once we run this test, the controller should be able to know how to reach the data nodes. Okay, it's running MapReduce jobs and it's going to assign these jobs to several data nodes, and hopefully it's going to finish within a few seconds. Okay, so I did a TeraGen just now. If we want to see the outcome of that TeraGen job, we just point to this particular port in our ComC, which is the controller, and we should be able to see that the state is succeed. Okay, after our TeraGen, what I will do is I'm going to run a TeraSort, okay, which is pretty much sort the data that was previously generated in the previous script. Okay, So again, the controller is going to allocate this job to some of the data nodes, and again, this should finish within a few seconds as well. Alright, our job is done. Let me just quickly refresh this browser. We should be able to see two jobs. And if we take a look at one of the jobs, we will see how fast was the performance for this particular run. So we did two maps, one reducing this one, okay? We can pretty much grab all the details from our job tracker. Alright, that's all we have for this video. Thank you so much for watching.